Assalamualaikum and hi class, welcome back to my video. In this video, we're going to talk about two-way ANOVA analysis. Right, so in our virtual class, in our previous virtual class, we had discussed about one-way ANOVA analysis, which is the analysis that you can conduct if your study involves one factor, one independent variable and one dependent variable, for the case of 3 or more population means. Okay, so in two-way ANOVA, it is the analysis that involves two factors, okay, two independent variables and one dependent variable. But why don't we just recall what we have in one-way ANOVA? So in one-way ANOVA analysis, your H-now statement is saying that all population means are equal, which is also equivalent to saying that there is no effect, there is no relationship between independent variable and dependent variable. Okay, on the other hand, your H1 statement is saying that at least one population mean is different, which implies there exists an effect. Okay, there exists a relationship between independent variable and dependent variable. So this is the H1 for your one-way ANOVA analysis that involve only one independent variable and one dependent variable. Okay, so untuk two-way ANOVA, so these are the assumptions that you need to fulfill if you want to conduct a two-way ANOVA analysis. Number one, you need to make sure that the population under study follow a normal distribution. Second, you need to make sure that the samples are random and they are independent of each other. So this is actually similar to the assumptions for one-way ANOVA analysis. Okay, even the third point is still the same as one-way ANOVA analysis. We need to assume that all the populations under the study has same unknown population variances. Okay, and then the fourth assumption is that observations are taken on every possible treatment. So yeah, we're gonna talk more about this later. And then the fifth assumptions is that the number of replication is the same for each treatment. Okay, this is important. And number six, the number of replication per treatment must be at least 2, which means that if your experiment has 10 treatments, okay, so treatment 1, treatment 2, treatment 3 until treatment 10, so each treatment has to be at least 2 replication. You need to collect at least 2 data from each treatment. Okay, your data collection has to be at least 2 from each treatment. And if treatment 1 you collect 3 data, so the second treatment also you must collect 3 data. Third treatment also you must collect 3 data. So all 10 treatments must collect 3 data. Okay, same number of replication, and the number of replication must be at least 2. Okay, so these are the assumptions that you need to fulfill in order to conduct a two-way ANOVA analysis. Okay, yeah, this is the model. Yeah, you can look at this, but you don't really need to pay so much attention to this. Okay, so this is quite theoretical. So since this is about statistics, I'm not going to go further into this discussion. Okay, now let's consider a situation in which you have a study that is to investigate the effects of learning mode. Okay, so let's say we have a face-to-face mode ataupun online mode. Okay, so we want to investigate the effect of learning mode and different types of syllabus on students' performance for course applied statistics. So let's just say this is the study. Okay, so in this case, we have 2 independent variables. What are the factors here? Yep, the learning mode and also the types of syllabus. So in this study, we want to see whether learning mode and types of syllabus affect the students' performance. So yep, these are the 2 factors here. So yeah, we can assume we can consider learning mode as factor A and types of syllabus as factor B. So the dependent variable here is students' performance. Okay, so you will collect data about the students' performance. All right, so you will need to conduct a number of treatments for this study. Okay, you need to test all possible treatment. You see, learning mode, there are 2 levels for learning mode, which is face-to-face and online. There are 3 levels for types of syllabus, which are syllabus A, syllabus B, and syllabus C. You need to conduct this experiment in a way that you consider all possible combinations of these 2 factors, meaning that you will have one experiment, okay, in which you do a face-to-face learning using syllabus A. And then another experiment, okay, another treatment is to use face-to-face mode with syllabus B. And then face-to-face mode with syllabus C, and so on. Okay. So you need to conduct this experiment in a way that you will test out all possible treatments. So you have to combine all the levels in factor A and also factor B. So in other words, the number of treatments here, which is K, is equals to A multiplied by B. Okay, A here is the number of level for factor A, which is 2 levels, face-to-face and online. And B here is the number of levels for factor B. Okay, so which in this case we have 3, syllabus A, syllabus B, and syllabus C. So yeah, 2 multiplied by 3, you will get 6. Okay, so this is how you calculate or how you determine the number of treatments for a two-way ANOVA analysis. Okay, so you need to make like 6 batch of, you need to conduct 6 experiment with these 6 conditions. Okay, and in each experiment you need to record at least 2 data. So maybe you will select at least 2 students for this treatment, 2 students for this treatment. It doesn't matter 2 or 3, but at least 2. At least 2, And then if let's say you chose 5 students for this first treatment, so the second treatment also must have 5 students. The third treatment also must have 5 students. Okay, so you will have 5 data here, 5 data, 5 data, 5 data, 5 data, 5 data collection. Okay, understand? So from each treatment, you need to collect at least 2 data, and you need to make sure that all treatments has the same number of data collection. Okay, so that is two-way ANOVA analysis. We're trying to understand whether or not these 2 factors affect the student's performance. So when you have 2 factors, class, there are several possibilities. Maybe both factor A and B does affect the student's performance. Okay, maybe these 2 factors interact with each other to give effect to the student's performance. Or maybe, no, maybe only learning mode. Maybe type syllabus does not affect the student performance. Or maybe only the types of syllabus that affects the student's performance. Or maybe none of these 2 factors actually affects the student's performance. Okay, so when you have 2 factors, you will have like these several possibilities of what's the outcome. Jadi, in order to counter all these possibilities, the analysis for two-way ANOVA is not so direct as in one-way ANOVA. Okay. Kalau untuk two-way ANOVA, you will need to use this procedure. Number 1, okay, this procedure. Let's view this like you have 2 stages. The first stage is called the interaction effect. So this is how you conduct two-way ANOVA analysis. Interaction effect. Okay, and then the second stage is called the marginal effect. So why is there two stages in this two-way ANOVA analysis? Because we need to make sure that our analysis consider all these possible outcome of the relationship between the 2 factors and our response. Okay, so this procedure is divided into 2, first stage and second stage. So let's take a look at the first stage. It is called the interaction effect. Okay, so what do you do in this first stage, class? What we do here is we want to test whether factor A and B interact with each other to give effect on the response. Okay, so in your HNAL, you will see that there is no interaction effect between factor A and factor B, meaning that these 2 factors does not interact with each other to give effect to your response, to give effect to your dependent variable. And in H1, our statement is saying that there is an interaction effect between factor A and factor B. So class, these two statements for HNAL H1 is fixed. Okay, meaning that you don't need to you just need to memorize this. Okay, so for every two-way ANOVA analysis question, this is the H now H1 for the first stage. Okay, for the interaction effect. No interaction effect, there is interaction effect between A and B, between factor A and also factor B. So let's say you pun conduct the experiment. Okay, you also need to calculate F test. Okay, you need to calculate F test using the two-way ANOVA table, which I will show you later. Okay, so you conduct F test. So let's say the decision, you calculate F test, you compare F test to the F critical value. So let's say the decision say that reject H null. Reject H null. Okay, so reject H null ni maksud macam mana? So you reject H null, meaning that H1 is true. So if H1 is true, it means that there is interaction effect between A and B. So if there is interaction effect between A and B, you will stop your analysis here. Habis kat situ. You don't need to do this anymore. Okay. If your first stage hypothesis testing gives you reject H null, okay, meaning that there is interaction effect between A and B, so your two-way ANOVA analysis stops here. Okay, your two-way ANOVA analysis ends at this first stage. You don't need to go into the second stage. Okay. Kan? Boleh? So that is if. Okay. Let me choose erase all. Okay. So that is if the decision in your hypothesis testing here is to reject H null. But if your decision is to don't reject H null, meaning that H null is true. Okay. H null is true. H null is saying that there is no interaction effect. Okay. If no interaction effect between factor A and factor B, then you need to go into the second stage, which is the marginal effect. Okay, so you need to go to the second stage only if your first stage decision is to don't reject H null. Okay, so if there is no interaction between factor A and factor B, then you need to test, okay, in marginal effect. Okay, so when you go into marginal effect, the second stage, you will need to conduct two hypothesis testing. Okay, one is the row effect hypothesis testing, and the second is the column effect hypothesis testing. Okay, jadi macam mana tu? Okay, so in the row effect hypothesis testing, your H null is saying that there is no effect of factor A, and your H1 is saying that there is effect of factor A. Okay, so that is your H null H1 for the row effect hypothesis testing. Yep, you also need to calculate F test and you compare it with the F critical value. So yeah, then you will make your decision and your conclusion. And then after that, you need to do the next hypothesis testing, which is the column effect hypothesis testing. And the statement is like this, okay? There is no effect of factor B and there is an effect of factor B. Okay, so this is two-way ANOVA analysis class. This is two-way ANOVA analysis. Maybe you don't need to go to the second stage. You can just stop at the first stage if the first stage decision is to reject H null. Okay, but if the first stage decision is to don't reject H null, you need to go to the second stage, okay, in which in the second stage you need to conduct another two hypothesis testing, which is the row effect and also the column effect hypothesis testing. So this is the procedure class. This is the procedure that you need to follow when you want to conduct a two-way ANOVA analysis. I think you will get a better understanding of this process when I explain to you the example. Okay, so stay tuned on to my next video to listen to example for two-way ANOVA analysis. Okay, class? Stay tuned.